He will not Good morning. I'm Valerie Beryl, as you can probably guess, and I've got a very sort of serious topic for discussion this morning, and I realised I gave this title quite a while ago, and when I looked at the day today and I thought about it, I actually wondered if anyone would want to come on such a beautiful day when there's lots to do outside. So thank you for coming, and I'm going to talk about breast cancer, about causes and prevention, what we know now, and I'm going to give I'm an epidemiologist here in Oxford, and I'm going to give not only an epidemiological perspective and a historical perspective too about what people have thought really over the decades about breast cancer and what caused it, because anyway, the bottom line, as you'll see, is that ideas people had a long time ago have turned out to be true, and we've been a bit misled over the last few decades, but I'll get to that. Now, I'm also going to, for some of you, I'm sure you've got different reasons why you're here, and I think if, I would presume that some of you have breast cancer or have relatives with breast cancer and have particular questions. I'm very happy to answer the questions either generally or later. But if any of you are here because of nostalgia for epidemiology or for your time at medical school or something here in Oxford, I do want to just start to remind you that Richard Dole was the Regius Professor of Medicine here from during the 1970s, and he really was responsible for a lot of the development of just medical research and biomedical research in Oxford. He really, in that capacity as Regius Professor, and I now work in the Richard Dole building, which is a new building that went up in 2005 near the Churchill Hospital. There's now quite a big biomedical centre there. There's a Wellcome Trust. There's a huge sort of cancer biology building here. This is the sort of epidemiology building. There's a genetics building just opposite. Now epidemiology, for those of you who don't know what it means, its origin is from the word epidemic, or from epi, the part, the epi part comes from the idea of epidemic, which is really upon, epi means upon, and demos is the people. And it really started, epidemiology as a discipline started with the study of infectious diseases and epidemics. And a lot of the research over many centuries was really concerned with why the plague, the epidemics of the plague and so forth, and people started analysing statistics to do so. And it was really after the Second World War that people started looking at, not entirely but largely, at non-infectious diseases and trying to understand them. And Richard, as I think many of you know, was really one of the really key figures in showing by epidemiological methods that smoking caused lung cancer. And he did this work, and I'm just going to show you, although it's not really related to what I'm talking about, but just to show that he did his original work in 1950. He actually died in 2005, and he saw over, this is in the UK, death rates from smoking-related cancers from 1950 to 2005, and you can see the huge, that actually when he did his original research, was largely lung cancer contributing. His rates were going up, but not entirely lung cancer. Much lower in women, but rates were going up. But since about 1970, look at this huge drop. And in women, rates went up and they dropped more recently. And this huge drop is almost entirely due to people stopping smoking, not young people not starting, and so it really shows how important it is for people who smoke to give up, and to think that over his lifetime he saw from what was just a sort of growing epidemic disappear. So disease rates are not constant over time. You can do things about them. And I'll just point, because another interesting just sort of historical fact is he did his original research first research in 1950, and it wasn't until 1970, which is 20 years later, that people really took it seriously and the government started saying people shouldn't smoke. And there's quite a long lag between first really quite serious, quite convincing results and someone taking note of it. And it must have been, and I know it was frustrating because at that time he was very attacked by for his work by, obviously, tobacco companies, but by other scientists too. It took a long time to accept these results, but he lived long enough to actually see this huge benefit. It really is quite phenomenal. Now, I'm just going to go back to breast cancer now, which is what I'm going to talk about. And I'm going to, and the reason why I'm talking about breast cancer, well, for many reasons, but breast cancer is now the most common cancer, and these pie charts just show the distribution. It doesn't show how many cases, but in developed countries, breast cancer is the red there, is the most common cancer amongst women in developed countries, and it's 600,000 cases a year, something like that. Now and I think probably everyone in the room would know that, lung cancer is number 3, and is still going up in many places. Now, in what you may not know is in less developed regions now, 2002, breast cancer is now the most common cancer in developing countries too. India, many countries, it's now most common cancer in women. It used to be cervix cancer, which now there's a vaccine for, and that's really very promising. So we've got, and I will talk later about how the rates are increasing really very rapidly in less developed countries. But so breast cancer is now the most common cancer in women, both in developed and developing countries. But the rates are not, these are just proportions of cancers, but the question, but there are far more women in less developed countries than in more developed. And if you look at these incidence rates per population, if you like, around the world, the red is the highest rates, and you can see it's in all the Western countries, basically, the developed countries. And then the rates go down, orange, yellow, light green, and dark green are the lowest rates. And in this particular figure, and you can see it's China, India, many parts of Africa, the rates are much lower. And there's about a 6-7-fold variation between developed and developing countries. And what I'm going to talk about today is really why, as an epidemiologist, I'm asking why are those differences and talking about why those differences exist. I'm not talking about what happens in cells or other, because one can say, well, you know, what are the changes in cells that lead to cancer? I'm not talking about that sort of thing. I'm talking about why we've got this difference. And this is in 2002, and as I've implied, rates are increasing in these green countries and in the orange. Most everywhere rates are increasing, but particularly in the areas where rates have been low in the past. And the way I'm going to talk about this, and it's not too numerical, although we do deal with numbers, is I'm going to talk about, if you take those same World Health Organization figures, these are from World Health, the International Agency for Research on Cancer, which is a branch of World Health Organization. If you take those figures and you actually look at the probability of having breast cancer by a particular age, and this is up to age 70, it's about 6% in developed countries. Now, you may have heard figures like 10%, because this is often said in the media and so forth as 10% in developed countries. It is 10% if you go up to about 80, because you can see how breast cancer rates go up with age, which is something a lot of people don't actually appreciate. If you went up to age 80, it would come to about 10%. So it is true that by age 80, about 1 in 10 women would develop breast cancer. But I'm using 70 because the figures are not very reliable in sort of rural parts of Africa and Asia until after age 70. So we've got here, and I'm going to talk about why this gap exists. And I'm going to keep coming back to this graph, showing this gap and seeing how much of this difference can we explain by things we know. So if you just remember, and this is the one figure I want you to remember, it's about 6 times higher, 7 times higher in developed countries than in rural Africa and Asia. So there's that sort of range of rates. So let's go back. I said I'm going to go back through history. Now, if you go back, I mean, you can go back, and it's you can go back to paintings in the Egyptian time, and you can, and people have shown that you can see pictures that women were drawn with a sort of puckered breast as if they had breast cancer, right back to sort of very thousands of years ago. But the first description of a kind of cause, if you like, of breast cancer was Ramazzini, who's very famous, who wrote really the first treatise on occupational disease. And he mostly talked about lung diseases in miners and so forth, all the sort of classic occupations. It was really the first very thorough discussion of role of occupation disease. But he actually mentioned at the time, in 1743, that breast cancer wasn't, and he called it an occupational disease of nuns. And, well, he didn't, it was in Italian, but equivalent of that. And so and it was obviously, in a way, you could say it was something that was known about at that time. But again, there were no figures. But not long after that, another Italian called Rigoni Stern, who was the equivalent of the Minister of Health in Verona, had collected statistics on causes of death in women or men and women in Verona over an 80-year period, 1760 to 1839. And what his figures showed was that actually 2.7% of nuns, and quite a large number, died of breast cancer, compared with 0.4% of other women. Now, if you look at that, that's a seven-fold difference. And that's the same level of difference that was in Italy amongst Italian women, whether they were nuns or not nuns, that existed a few centuries ago. So, because often one thinks, oh, there's so many differences between people in India or Africa and living in very rural, primitive conditions, us now, it could be infinite numbers of things, genetics, or all sorts, and I'm going to talk about all of these. But this is in the same population, if you like, nuns and others. There was about the same range of difference. And then, this is probably a bit too, but then not much was done about, sort of statistical about breast cancer until the early 20th century, when the League of Nations actually had a health organization based in Geneva, which was the forerunner of the World Health Organization. And in 1925, they set up a subcommittee on cancer, and they were particularly interested in breast cancer and cancer of the uterus. And they published these figures. This is taken from their 1925 report, showing, and it's a nice little graph, it looks a bit like one I showed you before, but they showed, this is the mortality rates, not incidence rates, for breast cancer by marital status. And you can see that single women had higher rates. Married and widowed were rather similar, but single women at every age had higher rates than married women. And so this was a little step forward, saying, well, it's not just nuns, but even amongst just in the general population, single women had higher rates than married. And this fit with this idea that, the idea that it was something to do with childbearing, because that idea was there, and I'll come back to that in a minute. So that was extending the idea a little bit further. And now, I know this session is about women. I think when I was asked to speak, it was something to do with women in science in Oxford. So I'm just going to digress a little bit and talk about it, because there was a woman from the UK called Janet Lane Clapon, who was at that meeting in the Health Organization in 1925. But in 1926, she published this report. She was in the Ministry of Health, and she published a really absolutely beautiful report on breast cancer, trying to look at the causes. She called it then, with reference, says cancer of the breast, a further report. She'd done one on survival, showing that if women got breast cancer, how bad the survival was. But she published a further report on cancer of the breast with special reference to antecedent conditions, in other words, causes, what came before. And she studied 500 women with breast cancer in London and Glasgow, and she picked controls, women in the same hospitals who didn't have breast cancer, and compared their characteristics. And what she found was that the average number, even if she found that same thing, that there were more single women with breast cancer, but even if she confined analysis to women who were married, the women with breast cancer had fewer children, 3.5 on average compared to 5 women who didn't have breast cancer. And she also found that women with children were less likely to breastfeed. Now I'll return, but I'll just tell you a little story about her, because she published a number of absolutely beautiful reports and for the Ministry of Health, as it was then called, not only for women's health, but also on child health, on the effects of supplementation, food supplementation, and so forth. And one day her publication stopped, and one of my colleagues, was sort of interested in what happened to her, and did a lot of research, and it took a long time. Anyway, what was discovered was that she ended up marrying the person who was the sort of chief medical officer, or the equivalent, who'd been widowed, and she married him. And when, at that time, you married, you could no longer be a civil servant. That's right. So someone like her, who became Lady something or other, I can't remember what, who did absolutely stunning research, really groundbreaking in many ways, when she married, she just disappeared from the face of research anyway. And it's hard. It's not that long ago that that was true. So it just gives you pause, and it's a sort of distraction, but something we need to think about, how far we've come in actually quite a short time when you look at the time scale even of people thinking about breast cancer. So, but anyway, to just go back to the main point, that really starting with Ramazzini and Lane Capon's results really sort of supported that. It was really thought that it was obvious almost that the major cause of breast cancer was if women didn't use their breasts for their natural purposes. And that was the sort of general view that was not rigorously tested, but prevailing. And what I'm going to show in the rest of my talk is that that's actually true. And that's true. And we've actually been misled for quite a while, and still are. There's still a lot of, and I'm sure, I'm sure many of you in the audience have stories, and I was speaking to someone before, and in the meantime, almost, for reasons that I'll explain, almost every hypothesis about anything has come forward, and some people have championed it one way or the other. But the evidence is, and I'll come back there, the evidence is that this is largely the true. And then I'm going to talk a bit about what we should be doing about it. But let's just go back. Now, why do we get misled? We got misled, and this is very technical. We're sort of, for people historical, for people who work in the field, and even if you are vaguely interested in breast cancer, it's hard to have escaped this idea of this concept of age at first birth. And it's a very funny word, but it means age women were when they had their first child. And this is a result, if you remember, Lane Capon had a study with 500 women. Well, this was a study in 1970, published in the World Health Organization bulletin, still French then, now it's all in English, of course. 5,000, so it's bigger than the other study. It was in 7 regions of the world, and they decided something else. They said that it's an international study of breast cancer reproductive experience carried out in 7 regions of the world. But they said basically the age woman is when she has her first child is what's relevant to breast cancer, which is true. I'm not saying that's not true. But they go on, and this is where we've gone wrong. They say births after the first, even if they occur at an early age, have no or very little protective effect. Now that's not true, as I'm going to show you. And then they say, go on, and the main thing that's really caught people's mind, the association with age at first birth requires different kinds of causal hypotheses from those that have been evoked in the past to explain the association between breast cancer risk and reproductive experience. And this has really misled people, and I'm going to show you why. Because remember this curve that I showed about rates in developed, this is the sort of cumulative rate in developed countries, six times higher than rural Asia and Africa. Now, there's not much difference in the age women are when they have their first child in developing countries, particularly for women. These rates sort of relate to about 1990 or so. And you see, women who were 70 or 60 in 1990 were born in 1930, or the ones who were 70 were born in 1920. And so when you think back at the, you have to remember that these rates, by definition, see, they refer to people from quite a long time ago. So in the 1930s and 1920s, when these women were born, or sort of soon after when they had children, we didn't have all the fancy contraceptive methods, and there wasn't, life was pretty primitive, if you like, in rural, very primitive in rural Africa and Asia, pretty primitive to some developed countries too, but nevertheless. And the average age, but anyway, the average age that women had their first child was about 25 in developed countries, and it was about 19 in rural Africa and Asia. So it was only about 6 years different. It wasn't that different. You know, things have changed now for these young people. I'm going to talk a bit about what's going on in these young ages later. But so the age wasn't different, and we know roughly from a number of studies how much for every year younger, what percentage decline, what percent breast cancers would be prevented, if you like, for each year younger at first birth. And it's not that many. So one's left here saying, well, what if everyone in developed countries had their first birth at 19 instead of 25? What would the cumulative rates look like? And the answer is not very different. It would drop a bit if everyone in developed countries had their first child at 19 instead of 25 at that age. So you see, so one's left with this huge gap. That difference still remains. And there have been, since 1970, you name it. I mean, this sounds very rude, and I'm sorry, but there have been hypothesis after hypothesis after hypothesis. Is it diet? Is it chemicals? Is it genes? Everything you hear on the radio most days is, you know, one of these is picked out and someone's found something on something. Now, the reason they're looking is because of this, the reason they were looking was because of this gap. Now, this is where I come in, or people and myself and colleagues in Oxford, in that I had done work before I came here on the pill, not on breast cancer more, but on the pill. And when I came to Oxford almost 20 years ago now, there was a huge argument in the literature and in the media too about whether the pill caused breast cancer. And if any of you remember, you don't hear it anymore, and it's because of this group and the work that we did. But this was, and people really claiming, one group claiming it did cause one with the other, and people, even to the point where at scientific meetings, people, it wasn't a meeting I was at, but I've heard stories of it. Just before I came to Oxford, there was a big meeting where the different protagonists would actually pull microphones from each other and shout it at each other and almost punch up in sort of the meeting. So it was very emotive amongst the scientific community, epidemiologists doing the work. So what we did is and I was quite neutral, which helped set this up, but I also had the help of Richard Dole, Richard Dole, Richard Peto, that you may have heard of. So Richard Peto does a lot of work now on smoking and lung cancer. Gillian Reeves, statistician. And the four of us set up this collaborative group on hormonal factors in breast cancer. And the idea was to bring together the original data, worldwide data, from all the studies in the world that looked at the pill and breast cancer to try and sort out what was going on. And we did sort out, and and I'll tell you, I'll just show, but it's a bit of a distraction to this, but I'll tell you the result anyway. But once we had information together from 100 studies, and this time sort of 100,000 women with breast cancer and controls, we could really look at other things in some detail before as well. And I'm just going to say the group meet every 5 years, and this picture was taken in 2005, and this was taken actually when Richard was taken. Richard was 90. It was in April of 2005, and he died in July after a very short illness, and he was really well and very much participating in the meeting in April, and we all miss him, and he really was a great man. But anyway, we started off. I'm just going to show, there are, for sort of public health reasons, I'm just going to show one slide on the pill and hormone replacement therapy, which is what I do a lot of work on actually, but I don't want to talk about, I can answer questions about it later, but this is all I'm saying about the pill and HRT. And what we found, and it might be a bit complicated, but don't worry too much. We basically found if this line here represents never users of the pill, and this line is never users of HRT, this little block here and that little block here are people who are past users who'd stopped the pill or hormone replacement therapy. And these points of how long they took it. This is less than a year, 1 to 4 years, 5. This is 10 years of use, and this is the same 10 years of use. And what we found, surprisingly, both for the pill and HRT, was that once people stopped, there was no increase of risk. Soon after people stopped, both of them, there was an increase. I'll go back. This is in current users. There was. I'll talk. But when people stopped, there was no persistent effect. And this goes against a lot of ideas people had about how cancers are caused. People often think cancers are caused by something that happens one day and then you get a cancer 20 years, 30 years later. Well, there's not actually too much. There's evidence of, I could have a whole lecture about these hypotheses, but there's sort of not that much evidence about whether just a single exposure at this point causes cancer a long time later. But actually, curiously, for both the pill and HRT, there was no residual effect, which is interesting biologically when I start talking, because pregnancies are different, as you may see where I'm heading, because a pregnancy when you're young actually does something. A pregnancy when you're young, having just said there's not that much evidence, for pregnancies there is. We know that a pregnancy at a certain age can prevent breast cancer when you're 70, but taking the pill, and in fact one of the reasons I was very interested in the pill is I expected the pill to produce a long-term protection, because I thought it was the same as a pregnancy, but it's not. Taking the pill is not the same as being pregnant as far as breast cancer goes. So, and that's quite important when I come to the end talking about what are we going to do. To see there's no persistent effects of either the pill or HRT. What we did find was that while people were taking the pill, there was a small increase in risk, 20%, which didn't seem to relate to how long you're taking it. There was a small increase in risk. HRT, we found there was a risk, but did go up the longer you've been on HRT. Now, this quietened the argument pill, and you really don't hear about it a lot. The HRT thing has grown a lot, and there's a lot of people wanting to doubt this association. But I'm just going to show you what happened in the US. I'm just going to show you one, because it's this residual effect for our purposes that's the most interesting. And in the States, because of it, I'm sure you have heard that, in the US there was a randomized trial because there was suspicion about a lot of the claims that were made about its benefit. But and showing really that the benefits claim were not right when you did a randomized trial. And use of HRT dropped considerably since 2001-2 when the trial was published. And so the drop in HRT use in the States, and it's happened in, these are just the first results to be published, but now it's been published in a dozen or so countries. HRT use dropped and breast cancer rates have dropped. And this is the first time actually in the US that ever seen a drop in breast cancer incidence, and this is in, and this followed the drop in HRT use. And what's more, HRT is associated with cancers that have estrogen receptors on them, with just the estrogen receptor positive tumours that drop, not the estrogen receptor negative. So that sort of supports, in a way, the idea that actually hormones, estrogens and progestogens, which are the hormones in HRT and in the pill, increase the risk of breast cancer. But when you stop, the risks go away. And that's not, again, what people generally think about hormones, but there's really a lot of evidence to say that's the way hormones act. But I'm just going to go back now to results from the collaborative group, where we really had 100,000 women, and we could look very carefully at all sorts of things. But we could look at the number of births a woman had, how many children in relation to breast cancer risk. This is no children, this line here. This is one child, I'm sorry, it's not, no, it's one child. And this is two. You can't adjust, this is holding age at first birth constant. There's a statistical reason you can't hold it constant, people who've had no children. So see, 1, 2, 3, 4, 5, see, it just goes down and down. It was a 9% reduction in risk per child. And what we found too, and I'm not showing here, is it was only births that went on to being a birth. It was only pregnancies that went on to a birth. Miscarriages and induced abortions didn't have an effect. So something later in a pregnancy seemed to be protective. Now, it could be breastfeeding, and it could be that all of that association was just breastfeeding, but there are enough women in the study to actually just look at women who had children but who never breastfed. So this is to see whether is it the childbirth itself? And the answer is yes. It's not as big, it's 7%, but even amongst, this is just restricting to women who had never breastfed, still each birth mattered. So that statement before that after the additional births don't matter isn't true, as you can see. And these are anyway. And then we could look at also duration of breastfeeding, how long in a lifetime, and holding the number of children constant. And again, you could see that but you've really got to get to quite long lifetime durations, years, before you start getting substantial reductions in risk. It takes a while, but there's again a clear reduction in risk. And you see, a lot of studies had been, particularly in the US, saying that the breastfeeding had no effect. In the US, the average duration of breastfeeding is about 3 months, you see. So comparing this line, 3 months, unfortunately 3 months doesn't do very much, you see, that against that. So you've got to breastfeed for a long time. But this was true in developing countries. This is not just because this is adjusting for study. This is carefully just comparing women within a single study, within a single country, within a single study, exactly the same age, exactly the same number of children, having their age, first age exactly the same. So this isn't due to other things. Because of such large numbers, we could really hold all that constant. And what's interesting about this and the pregnancies is this persists throughout life. So it's not the same as the pill. It's not the same as the effects of the pill and HRT. In principle, it's not like just when you take it or when you're pregnant something happens and then there's nothing subsequently. This is a persistent effect throughout life, in contrast to the pill. So when you then plug these things in the same way that I did before for just saying that if you just take age at first birth, there's no difference. But if you just take account of the larger families that were typical of women in this age contributing to this data set, and the longer duration of pregnancy, of breastfeeding, because the average duration of breastfeeding in developing countries in communities that have no contraception, not in rather sort of poor rural communities, about 2 years. So if you say, well, the more with typical larger family size, typical breastfeeding habits, breast cancer rates would be more than halved. It would go from 6.3% to 2.7%. It would almost halve just from those statistics, which are worldwide sort of the summary really of the worldwide evidence. It's really quite a substantial effect. Now we published this in 2002. I'm just going to, I think that's the next slide. I'm just going to tell you a funny story because this is, I mean, it was known, you know, there are many statistics about developing countries showing that it's typical to breastfeed. The usual was still about 2, but also if you go back to some of these old paintings of the time, that you know, if you see all these Madonnas and the children are pretty big, and it was usual to see quite big children. You know, this was sort of a typical scene, if you like, and around that time you saw women breastfeeding quite large children who could walk and talk, probably. And you know, I was rung by a reporter about this when we published. I'll just tell you, it's a bit, I'll try and, who said to me, is it really true that women in developing countries breastfeed for 2 years? And I said, yes. And she said, yuck. And it really illustrated, and there was nothing, it was, you know, there was, she'd been told to write this story, and then no story appeared. And it is very interesting that we've got to the point in society, I'm not suggesting, you'll see, I'm not suggesting this is the way forward, but it is interesting that in much of Western society now, this is thought to be yuck, like it couldn't be true. And anyway, a little aside, but there you are. That's how attitudes change. I'm not, you know, but it's very hard. The attitudes are now about, because the implications from some of these things are really quite striking. But before I go back to all the implications, and I'm not suggesting people have more children or they breastfeed, but these are the reasons which people find hard to accept. But it's not the only reasons. I don't want to say it's the only explanation. There are other things too. And I'm not going to go into them, but a lot of things related to growth also affect breast cancer risk. And just to say that the earlier people are at puberty, the younger women, and all of these favour higher rates in developed countries than developing. younger you are when you're at puberty, age of menarche, the higher the risk. Worse in developed than developing, who tend to have later ages of puberty. The earlier the age at menopause, or put it the other way, so the later the age at menopause, the higher the risk. And again, developed countries, women have their menopause later than developing. The taller you are, the higher the risk. Again, this is women in developed countries are taller. Now, weight is a bit complicated. It's only obesity in postmenopausal women. In premenopause, it doesn't matter, but that's when most of the breast cancers are. So basically, weight or obesity are also. So these are all things that, as I say, are sort of related to being big, or to be, and they're all, and their size, and they're also nutritionally related. There's another one as well, which is you can regard as nutritional, but or whatever you like. But there's also it's very clear that alcohol, number of drinks of alcohol that women have on average also is associated with risk. This is on average 1 drink a day, 2 drinks a day, 3 drinks a day, 4 is about a 20% increase in risk. So again, I have to say that because when we publish this, you get reporters ringing up and saying, oh, 3 drinks a day, you can't say that's bad. And again, because a lot of the journalists, certainly, and if some of you may well be journalists, they think this is quite normal. And so and I said that to someone, these findings don't sit well with the sort of contemporary woman. So anyway, but when we go back, sorry to keep saying it, but it is true. So when you go back, we've already talked about childbearing, breastfeeding. When you put in all those what I've called nutritional factors, they're not food. It's not food like fats or milk or something. People have looked at all these things, and you'll find a study that's found almost everything, soya, there are all these claims of different things, but actually it's just being bigger, eating more, giving you earlier puberty, make fatter, taller, all those things do affect risk. And it does bring it down. So it brings it down to 1.8. We're almost where we are in rural Africa, Asia. And we don't account, I think that these are not measured very reliably. Measurement error tends to underestimate risk. So it could just be, it's not like there's a gap. It's probably, that really accounts for almost all the difference. So, and we've known all of these, everything I've talked about, even the menarche and the puberty, we've known these things for a long time. But the important message is that they're probably the main things. Oh, I'm going to talk about genetics. I wonder what time it is. I'm just going to say a few things about genetics because there's been a lot of advances in genetics recently too. And genetic differences do explain within a situation, within a population, there is a range of risks. Most women, and really what I'm trying to say is this is a sort of distribution of the risk by if you knew people's genes, because we do know now a lot. Now this is so, if this is the 6.3% developed countries, and if we look at what we know now about genetics, which is a lot, we actually, 2/3 of all women would range between about 5 and 7.5. So that most women let's say in this country, we'll just say for sort of simplicity, even if we could type all the genes, and they're now like about half a dozen we know about, we could put most women in this sort of range, but they'd never go down to here. It's this kind of range. So the genes, and so it is true that there is a variation between women because of their genes, but it's about this much on this scale. And interesting, because the genetic work has been done in Asia and Africa, and the same genes have the same proportional effect in Asia and Africa. It's not that they don't, but because the background rates are so low, it's still 2/3 have a risk, but it's only between 0.8 and 1.2. So the genes act in the same way in all populations. But the thing is, the background rates are lower here and they're higher there. So genes are important, but they're not explaining any of this. And anyway, when it comes to prevention, which I'm talking about, you can't do much about your genes. Now, I'm just going to say, again, these are just because commonly asked questions, so I'm just going to answer some of these. what about, because often when I speak, someone says, oh, but why are the rates in Japan so low? And actually someone's already, so it is this thing, people say the rates in Japan are very low. Now, they're low because if we went out to 70 up here, we've still got a lot of Japanese women who had traditional, almost developing country type reproductive patterns. But if you just cut it, if you just amplify up to 45, where women now have, who are modern women, if you like, or I don't know if that's the right term, but I'll say it, where the rates are not, instead of 6%, about 1% of women in developed countries will have breast cancer by the time they're 45, compared to 0.2% in rural Africa, Asia. But look at these. You see, you've got these. Obviously, include Africa, China, India. But you see, you've got right up at this extreme, developed countries. Well, their statistics on Japanese Americans, Chinese American, African Americans, and their rates are exactly the same as Caucasian. So that in the US, people of the same sort of genetic makeup as down here, but living in the US, have rates the same as whites, Caucasians. But then you've got all this intermediate. You've got like Japanese in Osaka, Chinese in Shanghai were already up here, even though Chinese in rural China were down here. And you've got Japanese in Tokyo up here, Chinese in Hong Kong and Singapore. So even in countries that were more, in areas that were more westernized, you see, you've got the range right from here to here. And the Osaka Cancer Registry has been going a long time, and you can actually, these figures are for women who were born in 1945, but you can go from the Osaka Registry, you can look at the cumulative risk to age 45 for different years of birth. And women born in 1930, the cumulative risk was 0.26, so they were down here. For women born in 1955, they were 0.61 up here. So in one area that's collected statistics for a long time, women who were young enough to have changed, and these generations have changed a lot, you can see more than a twofold increase in risk. And the same is happening, and really very much so in China and in India, where the birth rate has fallen a lot quite recently. You can see in young women rates going up quite fast. So there's no, and that's what I sort of showed you also about even the cancer rates associated with smoking falling. The thing about statistics and national comparisons and things change over time. They change quite rapidly. And you have to always be aware that in certain age groups, things may be different and so forth. And that's, why, one can, anyway, you have to just be aware of that. But so given that we've got there's just over 1 million cases in about 2000, in year 2000, about 1 million cases of breast cancer every year. Now you can look at the trends and it's now the most common, as I said, in both developed and less developed countries. And you can look at the trends and very easily say, and that, I wouldn't want to be sort of quoted seriously, but it's in about 40 years' time, it's going to be 2 million. And much of those 2 million are people from developing countries, actually. So breast cancer rates are going to keep going on, and what are we doing about it? And is outside, it's not outside my area, but it's not something, unfortunately, epidemiologists can easily do. It was okay for smoking because it was easy to say stop smoking. But for breast cancer, you can't, it's really quite complicated. It's really, it's not complicated, but it is. No, it is. Because you need to be rational about it, and this is not so at the moment because, anyway, let me just go on, but it is hard because we know, first of all, we know it's the most common cancer in women worldwide. Incidence is increasing rapidly, particularly in developing countries. But we actually do know, we really do know the main modifiable causes, potentially modifiable causes, and we do know it counts for most of the worldwide variation in breast cancer. So, but if we want to think about it, it's not like a treatment. This is something, if we really want to prevent it, it's in healthy women. It's in women who haven't got breast cancer, has to be acceptable, has to be without serious side effects. So lots of people advocating giving women all sorts of hormone-blocking drugs for all their life, but that's not really serious in my view, because you can't expect someone to give, I mean, still you could argue 10% of women get breast cancer by the time they're 80, but 90% don't. And to make 90% take a drug for life that might cause side effects doesn't actually sit very well. And so you have to have something without side effects that's acceptable. Now we do know, and I'm just going back, what is easy to do. As I said, for smoking it's easy, you can just say stop smoking. But for women, now in the UK, there are about 45,000 cases a year. Now, if no one drank alcohol, no woman drank alcohol, it could be 5,000 fewer. If no postmenopausal woman was obese, it would be about 4,000 fewer. And it would be 1,000 fewer if no postmenopausal woman used HRT. I would have said 5 years ago it was 2,000 fewer, but actually use has halved, so now it's only 1,000. So all of that together is about 10,000, which is 25, bit over a quarter. But they're pretty, and you know, they're pretty hard to achieve, these things, except I think the HRT. But anyway, pretty hard to achieve. It's not like this is easy going, and it's not going to solve the problem anyway. It's going to reduce, but not solve the problem. But what about the thing that we actually is staring us in the face, but we sort of, most people don't want to believe, and I'm going to say that because it really is true, that the main cause has been known for centuries. It really has, and you know, the evidence, the worldwide evidence supports it. But it's really not an option. I mean, we've all become nuns, and that's really quite, it's got its benefit. And you know, and it's not like having no children or fewer or children late in life is disadvantageous. For many reasons it's advantageous in life. I mean, it's not like, you know, breast cancer isn't the only thing that one thinks about. So it's not, you know, it's not something that's sort of acceptable or likely change or sensible. So it's not, I'm going to say, it's an option to ask women to breastfeed, suggest they breastfeed for longer, but even, as I said, 3 months, I'm not saying no, but you've got to start breastfeeding each child for like 2 years to really, 3 years, because we have so few children. And probably that's not an option, but it's certainly something people could consider, but it's not, and it's really long-term breastfeeding. So what about mimicking the effects of childbearing? And this is, I only got 1 or 2 slides to go, but this is just a little picture to show you that during pregnancy, all sorts of hormonal changes happen. And I'm not going to say what they are. I hope you can't read what it is, just to show that things happen. Now, we know from epidemiology that short-term exposure in early adulthood to one or more of the, and it is the hormones of pregnancy and lactation, gives you lifelong protection against breast cancer. And we also know, you see, that when I give talks to an audience who are very much into hormones, they all say, well, we know it's estrogens and progestogens. The main hormones of pregnancy produced in the body are estrogens and progestogens. And I used to think that was so, and because we knew pregnancies protect against breast cancer, as I said before, I always thought the pill was going to protect against breast cancer in the long term because I thought it was the same as pregnancy. But the point is that there are lots of other hormones in pregnancy, particularly ones that affect the breast, like something called prolactin. And it does make you think. It's very hard for me to avoid the idea that really, why aren't we working out which of these hormones, and forget that it's because it's not estrogen progesterone. That's, you know, most of the work I've done has been on the pill and HRT. These things increase the risk of breast cancer in the short term and don't have a persistent protective effect. Must be one of these other hormones. Very few people are working on it. But if we could work out which it was, we should surely be able to work out something over a 9-month period or a bit longer maybe, that's like a hormone vaccine that you give to young women, and exposure for a short period would give, in theory, lifelong protection against breast cancer. Maybe repeated exposures, you know, a couple of times, but it would be something over a relatively short period which should protect in the long term. And you know, we've got the HPV vaccine, thank heaven, for cervical cancer, and it's almost a kind of equivalent idea, but it's not popular. So I'm going to finish there and say thank you for listening. And I'm very happy to answer questions. Okay.